This is the Milky Way galaxy in the center, and roughly around 10 million light years sphere surrounding the Milky Way galaxy is an area we call the local group of galaxies. In this area, there's approximately 80 galaxies altogether. 3 of these galaxies are spiral galaxies, which includes the Milky Way galaxy, the Andromeda galaxy, and the Triangulum galaxy. The Andromeda galaxy is the closest major galaxy to the Milky Way galaxy. As you can see, there's quite a few galaxies that are closer, but this is the closest major galaxy to the Milky Way. It's approximately 2.2 million light years away from the Milky Way galaxy. Now, let's take a look at the immediate neighborhood of the Milky Way. Two galaxies that are the largest dwarf galaxies are called Large Magellanic Clouds and Small Magellanic Clouds. Most all galaxies surrounding the Milky Way are dwarf elliptical galaxies or dwarf irregular galaxies. If in our neighborhood most of the galaxies are dwarf ellipticals or irregular galaxies, we think that maybe in everybody else's neighborhood the most numerous galaxies in the universe happen to be dwarf elliptical and also irregular galaxies. The two most famous galaxies that orbit the Milky Way are large and small Magellanic Clouds. They're seen by Magellan when he was circumnavigating the world, and when Magellan passed away, his sailors named the two clouds after him. In the southern sky, if you look up, you should be able to see two small clouds in the sky. This is called the Large Magellanic Cloud, and this is called the Small Magellanic Clouds. The Large Magellanic Cloud does not have a nucleus, and it's in irregular galaxies. There is all sorts of stars and nebulas here. There's also star formation going on. The Small Magellanic Cloud is a little further than the Large Magellanic Cloud. They're both approximately a couple of 100,000 light years away from the Milky Way galaxy, and they both orbit the Milky Way. They're also connected with a bridge of stars, approximately 43,000 light year bridge of stars connects the two galaxies together. Besides the Milky Way, we have the Andromeda Galaxy and Triangulum Galaxy as the two other major galaxies in this local group of galaxies. The Triangulum Galaxy is much smaller than the Milky Way, and there's quite a few places where stars are being born here. All these red patches are where the stars are being born. It's a spiral galaxy, and it's a SC-type galaxy. It seems to be gravitationally connected to the Andromeda Galaxy. This is the Andromeda Galaxy, and the Andromeda Galaxy has a little bit more mass than the Milky Way Galaxy. And they're both approximately the same, approximately 1,000,000,000,000 times the mass of the Sun. There are also galaxies orbiting the Andromeda Galaxy. We can see two of them here. They're two dwarf elliptical galaxies. There is one here. There is one here. These are dwarf elliptical galaxies that orbit the Andromeda Galaxy as a satellite. It appears that the Andromeda Galaxy and the Milky Way Galaxy are in a collision course. Eventually, in about 4 billion years, they will collide. During this collision, there's going to be a period of starburst where lots of stars are going to be born, and then there will be a collision between the black holes, and the black holes will eventually merge. Andromeda Galaxy has a black hole 55 million times the mass of the Sun. The Milky Way Galaxy has a black hole 4 million times the mass of the Sun. This is what's going to happen approximately 4 billion years. As we can see, this is the Andromeda Galaxy and the Milky Way Galaxy, and this is the Triangulum Galaxy. They're all going to be involved. It should be quite a sight from the Earth. I should see this gigantic galaxy, the Andromeda Galaxy, getting closer and closer to the Milky Way. So in the Earth's sky, this should be a very impressive scene. Although by that time, there probably won't be any human beings left on Earth. Most all galaxies in our neighborhood, with the exception of Milky Way, Triangulum Galaxy, and Andromeda Galaxy, are of the dwarf type, which means they're either dwarf elliptical galaxies or dwarf irregular galaxies. The two largest closest to Milky Way are Large Magellanic Cloud and Small Magellanic Cloud that orbit the Milky Way, but there's quite a few other galaxies. Altogether, about 80 galaxies. This is one of them. This is a typical dwarf elliptical galaxy. Elliptical galaxies have a few billion stars, whereas the major galaxies like the Milky Way have hundreds of billions of stars. This is an irregular galaxy, one of the galaxies in the local group of galaxies that orbits the Milky Way galaxy. Here's another irregular galaxy. It is inevitable that some of these galaxies will collide with the Milky Way and gravitationally will affect each other. One of these galaxies was the Sagittarius Dwarf galaxy. It collided with the Milky Way and we can see streamers still in place. Another galaxy that has collided with the Milky Way and has left some streamers is called Dwarf Canis Major galaxy. So this Canis Major galaxy is considered the closest galaxy to the Milky Way galaxy. Remember, Andromeda is the closest major galaxy to the Milky Way. Canis Major Dwarf Galaxy is the closest galaxy to the Milky Way. This red represents Canis Major Dwarf Galaxy, the blue represents the Milky Way galaxy. Farther out, approximately 50 million light years away, is the closest cluster of galaxies to the Milky Way. In fact, the Milky Way is gravitationally bound to it, and we are part of this cluster of galaxies called the Virgo clusters of galaxies. Virgo cluster of galaxies approximately has 10,000 members. This is the local group of galaxies here, and this is the Virgo cluster of galaxies here. It appears that the Virgo cluster of galaxies and some of the clusters of galaxies surrounding it are moving together, so we call this gigantic volume of space, approximately 500 million light years in diameter, Laniakea, which includes the Virgo cluster of galaxies, the Centaurus cluster of galaxies, and others that are very close by. This yellow represents the Laniakea, and this is a surrounding supercluster of galaxies. When we look within 100 million light years of Virgo clusters of galaxies, we can see quite a few other galaxies here. And all the galaxies appear to have been arranged in filaments. And this filaments most likely has to do with the amount of dark matter and the shape of dark matter in the universe that attracts the galaxies to become filament. Again, this is the Virgo cluster of galaxies, and this is the greater filament. And black holes